Okay, here we have the Algebra 2 Chapter 1.4 guided notes. Now here we're going to solve absolute value equations. In mathematics, we say that the absolute value of a real number is the distance. It's the distance away from zero on a number line. Now, we denote this by using straight bars or absolute value bars. So absolute value bars. And these absolute value bars act like parentheses, so they must be handled first. Alright, so here I've provided a number line, and really this is as blank as it gets. So I'm going to go ahead and start off by putting 0 here. And we're going to try and handle this problem, and we're going to use the number line to help us solve that problem. Now, we're talking about the distance away from 0. And, initially, what I want to do with this problem, I'm just going to ignore all this right now, just for now. I want to ignore that. And what I want to really pay attention to is the fact that we have absolute value bars. Okay? Now, what I've covered up in red is the absolute value of this stuff, whatever it may be, is 20. In other words, my distance away from 0 is 20. Well, when I look at my number line, I go all the way to 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So here I am at 20. So my total distance here is 20. Well, I can also go 20 in that direction, and that would leave me at negative 20. So I know that whatever is under here is either going to give me 20 or it could give me negative 20, because the absolute value of negative 20 is 20, and the absolute value of 20 is 20. So that must mean that whatever is in here is either equal to negative 20 or it's equal to 20. So now I'm going to go ahead and erase this, and we can see x minus 100 must be either negative 20 or it must be 20. So I'm going to say x minus 100 equals negative 20. And then I'm going to use this just to separate my work. I'm going to say x, oh, I got the blue one. That's okay. X minus 100 equals a positive 20. And clearly I need to add 100 to both sides, plus, sneak my 1 in there, plus 100. And so we get x equals negative 20 plus 100 is 80. And whenever I go over here and I add 100 to both sides, plus 100 and plus 100, I get x equals 120. And if I want to check my work, it's no big deal. X equals 80, so I put 80 in here. Well, 80 minus 100 is negative 20. And the distance away from 0 for negative 20 is 20, so that satisfies that. And I take this 120 and I plug it into the original. 120 minus 100 is 20. Well, absolute value of 20 is 20, so that definitely satisfies there. Now, a constraint is a condition that a solution must satisfy. Equations can be viewed as constraints, and the solution of the equation, or solutions of the equation, meet the constraints of the problem. Even if the correct procedure for solving the equation is used, the answer may not be actual solutions to the original equation. Such a number is called an extraneous solution. And we'll take a look at an example that might have that here. Okay, now, here, again, what I'm going to do is I'm just going to cover this up for just 1 second, just so we know and understand what I'm talking about here. Everything underneath that red dot to say the absolute value of that is equal to that. In other words, my distance away from 0 is 4x minus 8. Well, just like we saw a minute ago, that could be either negative 20 or positive 20, right? So over here, I could either be a positive 4x minus 8, or it could be a negative 4x minus 8. And notice how I use parentheses. So let's erase everything underneath there and see what we have. Okay, I have x plus 10 equals 4x minus 8. And let's separate our work a little bit. And I have x plus 10 equals a negative 4x minus 8. Well, let's handle this side first. I want to get my variables on one side and all my numbers and constants on the other. So I'm going to subtract 10 from both sides first. And I get x equals 4x minus 18. And now if I subtract 4x from both sides, 1x minus 4x is negative 3x equals negative 18. And dividing by negative 3, I get x equals a positive 6. Now, if I plug that back into the original, when I plug that back into the original, 6 plus 10 is 16, and I still have my absolute values. And 6 times 4 is 24, so I have 24 minus 8. Well, the absolute value of 16 is 16. My distance away from 0 on a number line for 16 is 16. So my 16 equals, well, 24 minus 8, yeah, that's 16. So this checks out. So my answer here checks out. All right, so going to this side, I need to distribute this negative first. This negative 1 gets distributed here and here. So I have x plus 10 equals minus 4x plus 8. Now I'm going to add 4x to both sides. And I get 5x plus 10 equals 8. And now I can subtract my 10 from both sides. And I end up with 5x equals negative 4. Excuse me, no, that's not negative 4. That's negative 2. And dividing by 5, and divide that by 5, I get x. I don't think we can see that. My answer is going to leave me with x equals negative 2 fifths. Now let's check our work. I'm going to plug negative 2 fifths. I'm going to plug negative 2 fifths into both sides. So, into everywhere I see an x, excuse me. Where I see my x here and here, I'm going to plug negative 2 fifths. So I'll have the absolute value of negative 2. Seriously, all these text messages in the middle of the recording, do people not know? I'm sorry about that. I apologize for the distraction. Equals, so the absolute value of negative 2 fifths plus 10 equals 4 times negative 2 fifths minus 8. Now let's just see if that's true. Well, negative 2 fifths plus 10, well, that's going to be 50 over 5. 10 is the same thing as 50 over 5, and 50 minus 2 gives me 48 fifths. And now here I have 4 times negative 2, that's negative 8 fifths. So negative 8 minus, and 8 over 1, turn that into 5, 8 out of the 40. So I get a negative 48 fifths. Now, my question is it true that positive 48 fifths equals negative 48 fifths? No. So, I can then state that this solution here is, my solution here, this guy, is extraneous.